Unit 6. Development Standards, Non-Residential Structures, Floodproofing Options and Requirements. Non-residential structures in special flood hazard areas have more compliance options than residential buildings. While elevation is always an option, non-residential buildings may also use dry floodproofing or wet floodproofing techniques, each with specific requirements and limitations. Dry floodproofing involves making a structure watertight below the base flood elevation through the use of waterproof materials and construction techniques. This approach attempts to keep floodwater from entering the building entirely. However, dry floodproofing has significant limitations and is not allowed in coastal high-hazard areas where wave action and high-velocity flows make it impractical. The key requirement for dry floodproofing is that the structure must be watertight below the base flood elevation. This means that walls, floors, windows, and all penetrations must be sealed against water entry. All materials used below the BFE must be waterproof or water-resistant. Dry floodproofing requires certification by a registered professional engineer or architect. The professional must certify that the structure is designed to withstand hydrostatic and hydrodynamic loads, including buoyancy, during base flood conditions. This certification must include detailed calculations and specifications. Human access to dry flood-proofed buildings during floods must be considered. Emergency exit routes must remain available, or alternative egress must be provided. The building must also be designed so that occupants can safely evacuate before flood levels become dangerous. Mechanical systems in dry flood-proof buildings present special challenges. All utilities must be watertight below the BFE or must be elevated above the base flood elevation. This includes electrical systems, plumbing, heating and cooling equipment, and any other building systems. Wet floodproofing, in contrast to dry floodproofing, allows floodwater to enter and exit the structure freely, minimizing structural damage from hydrostatic pressure. This approach accepts that flooding will occur but designs the building to minimize damage. Buildings using wet floodproofing must be constructed with flood-resistant materials below the base flood elevation. These materials must be able to withstand direct and prolonged contact with floodwater without sustaining damage that requires more than cosmetic repair. Wet flood-proofed buildings must have flood openings that allow automatic entry and exit of floodwater. These openings serve the same function as those required in residential crawl spaces and enclosures, equalizing water pressure on both sides of walls. All utilities in wet flood-proofed buildings must be elevated above the base flood elevation or must be designed to be flood-resistant. This typically means locating mechanical equipment on upper floors or on elevated platforms within the building. Mixed-use buildings. Buildings that contain both residential and non-residential uses must meet the most restrictive requirements that apply to any use in the building. This means that if a building contains apartments above commercial space, the entire building must meet residential standards. The residential portions of mixed-use buildings must always meet elevation requirements. The lowest floor of any residential unit must be at or above the base flood elevation. Dry floodproofing is not allowed for residential uses under any circumstances. Non-residential portions of mixed-use buildings may use floodproofing techniques appropriate for commercial uses, but the design must be integrated with the residential requirements. For example, if the commercial space is dry floodproofed, the residential areas must still be elevated. Means of egress from mixed-use buildings must be carefully designed to ensure that residents can evacuate safely during flood conditions. This is particularly important when commercial areas are flood-proofed and may be inaccessible during floods. Historic structures. Historic structures present unique challenges in floodplain management because elevation or floodproofing requirements may conflict with historic preservation objectives. NFIP regulations provide some flexibility for historic structures, but the options are limited. A structure is considered historic if it is listed on the National Register of Historic Places, or if it is determined by the Secretary of the Interior to contribute to the historical significance of a registered historic district, or if it is designated as historic under a state or local historic preservation program. Communities may determine that certain floodplain management requirements would preclude the structure's continued designation as a historic structure. In such cases, alternative approaches may be considered, but any alternative must not preclude the structure's continued use or occupancy. When historic structures are substantially improved or substantially damaged, communities have more flexibility in determining appropriate requirements. The community may balance historic preservation concerns with flood safety objectives. Even when flexibility is provided for historic structures, basic safety measures should still be implemented where possible. This might include elevating utilities, using flood-resistant materials where they will not affect historic character, or implementing emergency procedures to protect occupants during floods. Critical facilities. Critical facilities are those structures that are essential for community function during and after disasters. These include hospitals, fire stations, police stations, emergency operation centers, utility facilities, and schools that serve as emergency shelters. NFIP regulations do not specifically address critical facilities, but most communities adopt enhanced requirements for these structures. The typical approach is to require protection to the 500-year flood level, 0.2% annual chance. Rather than the base flood level, critical facilities should be located outside special flood hazard areas whenever possible. When location in flood-prone areas is unavoidable, these facilities should be designed to remain functional during and immediately after flood events. Emergency access to critical facilities must be maintained during flood conditions. This might require elevated access roads, alternative transportation methods, or temporary flood protection measures that can be deployed when floods threaten. Utilities serving critical facilities need special protection to ensure continued operation during floods. This might include backup power systems located above flood levels, redundant utility connections, or on-site fuel storage for emergency generators. Industrial and special use structures. Industrial facilities often have unique requirements related to their specific operations and the hazardous materials they may contain. Floodplain management for these facilities must consider not only structural protection, but also environmental protection. Facilities that store or process hazardous materials must prevent the release of these materials during flood conditions. This might require special storage methods, containment systems, or emergency removal procedures when floods threaten. Large industrial structures may require special engineering analysis to determine appropriate flood protection measures. The size and complexity of these structures often make standard approaches impractical. Utilities and industrial processes that cannot be interrupted may require special protection measures. This might include flood barriers around critical equipment, waterproof enclosures for essential systems, or redundant facilities in non-flood-prone locations. Agricultural structures are often exempt from some floodplain management requirements because of their low human occupancy and agricultural use. However, they must still meet basic safety requirements and cannot create additional flood hazards for other properties. Storage facilities and warehouses typically use wet flood proofing techniques because of their large size and the impracticality of making such large structures watertight. The key is to ensure that stored materials either can withstand flooding or can be quickly moved to higher areas when floods threaten.